We have another example, and again we're supposed to check what's wrong with this circuit. Or maybe everything is fine. So from where we're supposed to start? There are many ways to do it, and I would solve this in this way. Voltage at this point, right? Let me call this point Vx, for example. Vx is equal 11.22 volts. Okay, so everything so far looks kind of okay, because this resistor is functioning. Why? Because if this resistor wouldn't function, okay, if this resistor would be open, okay, let's say this resistor doesn't exist, my voltmeter would measure just 25 volts, no matter what values of the resistors we have over here. If this circuit would be open over here, my voltage over here would be 25 volts. If this resistor would be shorted, I would measure over here negative 6 volts. So it means that this resistor is okay. I can trust this resistor, at least at this moment. So what I'm going to do right now, I'm going to find I4. Okay, I4. But in order to find I4, I have to find voltage across resistor R4, because I4 is equal V4 over R4, where V4, voltage across this resistor, is nothing else just the difference of these two voltages, okay? Because current is going to go this way, okay? By the way, current is going to go this way. Why? Because this is higher potential and this is lower potential, and as you know, we use conventional current flow, so we assume that current flows from positive to negative. Okay, so if this is my positive voltage and this is my negative voltage, so current is going to go this way. So keep in mind that anytime current is entering the component, there is positive sign, and anytime it's leaving, is negative. So I have positive, negative, and positive and negative. Okay, so what I'm going to do, I'm going to right now find voltage across resistor R2. This is nothing else, just Vx minus, in this case, negative 6 volts over R4, which is equal 5 kilohms. So my Vx is equal 11.22 volts. Negative times negative gives me positive 6 volts over 5 kilohms. 11.22 plus 6 is equal 17.22 volts. Okay, divide by 5 kilohms. Okay, so I have, okay, this is K, by the way. We have 17.22 divided by 5 exponent 3. This is equal 3.44 milliamps. Okay, this is my I total. The current which is flowing right now by this circuit. Next, what I would do, I would simply use this current and find the voltages across these 3 resistors. As I said, there are many ways to solve this problem, but I'm going to use this one. So V R1, okay, is equal, okay, I total times R1. Keep in mind that this is the series circuit. In the series circuit, current is the same, so I can say that I total is equal to I1 is equal also to what? I2 is equal to I3, and this is also equal to I4. And in our case, this is equal 3.44 milliamps. So I total, I can use I1, I2, or I3, I4. Doesn't matter because this is series circuit. In series circuit, current is always the same. So I have 3.44 milliamps times R1, 1 kilo ohm. This is equal 3.44 volts. Okay, for those of you who have difficulties with the calculator, I'm going to do this one more time. The calculator, 3.44 exponent 3 negative times 1 exponent 3 equals 3.44 volts. So V2, the voltage across resistor R2 is equal, again, I total times R2. This is equal 3.44 milliamps times 2 kilo ohms. This is equal 3.44 exponent 3 negative times 2 exponent 3. This is equal 6.88 volts. 6.88 volts. Again, I'm doing this on the calculator. Just make sure that everybody knows how to enter these values into the calculator. So if VR3 is equal I total times R3. You can also use I3 times R3. This is equal 3.44 milliamps times 3 kilo ohms. This is equal 3.44 exponent 3 negative times 3 exponent 3. This is equal 10.32 volts. 10.32 volts. Now I have to verify, okay, which voltages, okay, subtracted from 25 volts will give me 11.22. Okay, so I'm going to write that Vx is equal 25 volts minus, okay, and I'm going to, let's say, try with the voltage VR1. So 25 minus VR1. Okay, so I'm going to have 25 minus VR1 is equal 3.44, okay, is equal 21.56 volts. Okay, so I still have room to subtract something else in order to obtain 11.22. So from this voltage I can subtract also 6.88. If I'm going to subtract 6.88, I'm going to have a little bit more than 11.22. If I'm going to subtract 3 of them, I'm going to have much less than 11.22. So what I'm going to do, I'm going to subtract right now voltage across resistor R3. So this is minus 10.32. This is equal 11.24. Okay, so I would say this is VR3. So I have 25 volts minus 3.44 volts minus 10.32 volts is equal 11.24 volts. Okay, so this is very close to whatever I'm measuring over here. So it means that my resistor R2 is short. So let me repeat myself one more time. Let me show what I really meant. I found the voltages across each of these 3 resistors, okay? And someone is going to say, okay, I'm going to subtract 25 minus 3.44 minus 6.88, okay? We got more than 11.22. We get 14.68. If you are going to subtract the third current minus 10.32, okay, 10.32, you will obtain 4.36. The voltage over here is much lower than this one, so it means we subtracted too much. But if you are going to, from 25, subtract 3.44, okay, it looks kind of okay, and minus 10.32, you will see that you will get 11.24. This is basically what I got over here. So it means that resistor R1 and resistor R3 functioning properly, and I got the problem with resistor R2. R2 is short, has short, internal short, okay? So it means that this resistor has to be replaced. And this is simply the solution to my problem.